So Vehicle's our platinum sponsor. They've gone like above and beyond to support Laracon Online. Adam used to work there, just a nice little bonus. And so basically what Vehicle does, they're a team of consultants that really specialize in Laravel. So if you need them to build out a full project, or just given our audience here, more likely if you're like growing and you need to quickly scale up the team, or you need to add a team in to build maybe a component of your application or something like that, then you should definitely check out Vehicle, talk to them. They do Laravel dev all day, every day. And so they're really great to work with. So definitely check them out at vehicle.com, spelled a little differently than the standard way. So check that out, and definitely say thank you to them on Twitter first, please. That would be wonderful. All right, so Adam is here. He's going to talk about testing, which I know you're all excited about. We're going to get out of the front end for a little bit, get onto the server. And so take it away, Adam, and you can share the screen down below.
All righty, let's see what I got here. Do the whole screen, I guess.
Yep.
This looking okay?
Yep, looks good.
Radical. Okay, let's get the slides going. So here we go. This talk was originally going to be called Lies You've Been Told About Testing, but I thought maybe lies was a little bit strong. Maybe it's more alternative facts that you've been told about testing. So if you've ever tried to learn testing and you've kind of been hanging out on the internet, trying to figure out what the best practices are and figure out, the right way to do things, you've probably heard recommendations and advice from, experts online, things like this sort of thing. Almost all of your tests should be unit tests. It's okay to have some integration tests, but unit tests are like your vegetables. Integration tests are like dessert. Yeah, they're not going to kill you, but they're probably not good for you either. Or another classic is your test should never touch the database. There's no reason when you're testing your application code that you should need to actually integrate with some external network-based service like MySQL. Why do you need to run tests that hit MySQL? Don't you trust that MySQL already works? You didn't write the database code. You're writing your own application code. There's no reason that your tests should ever have to hit the database. Or my personal favorite, which is that if you can't test your code in isolation, it's poorly designed. You should be able to easily test all the code in your application in small, discrete little units. You should be able to test one class at a time, isolate that class from any other classes that it would normally talk to, and focus on just testing the behavior of that class. If the way that you've built your application makes it hard to do that, well, then you're doing something very, very seriously wrong. You've really messed up. So if you're trying to take kind of all these pieces of advice or recommendations or best practices into account, you might end up building something like what I'm about to show you. So imagine we were working on an application, and one of the features that it had was being able to add products to the system. And a product is really simple. It just has a name, a description, and a price. And we want to drive out, some implementation of this and kind of get it working, trying our best to kind of follow all these best practices that we've heard about online. So let's dive into some code here. So here's our products controller. And you can see we have a products controller here that has a constructor where we take all of our dependencies as injected dependencies to make sure that when we need to test the controller, we can easily control the dependencies and pass in mocks and stubs and spies and stuff like that. So it takes a reference to Laravel's guard, right? So we can find out things about the logged in user. We take a command bus because we're going to try and use this command-oriented architecture to keep sort of messy business logic out of our controller and kind of isolate that somewhere else where we can kind of easily test that in isolation as well. We also take a redirector because we need to be able to redirect the user back to the main products page when we're done adding the product. And we don't want to use a global function or a facade for that or anything because, again, we really want to be able to test this products controller in pure isolation. So we assign some dependencies here. And then finally in our store method, we take an incoming request and then we put together this add product command, which contains all the pieces of information necessary to put together a new product. So we get the current user's ID from our guard. We get the name of the product from our request, the description and the price also from the request. And then once we put that command together, we go ahead and dispatch that command through our command bus to be handled elsewhere. Then finally, we use our redirector to redirect to our products.index route. It's really simple, right? Like we're not worrying about things like validation handling or any of that stuff here because I'm trying to keep the example easy to understand. But yeah, it's very simple code. There's not much going on here. The controller clearly just has kind of one job: put together the command, send it somewhere to be handled, redirect back. Very kind of focused. So let's take a look at some of these other classes. Maybe we'll look at the add product command next. So this is just stupid simple class. It's basically just a data structure. It takes in some data, we save that away on some properties, and then we go ahead and expose those through some getters so that we can get at that data when we need to actually do something with it. Nothing really fancy going on here at all. Maybe next we'll look at the command bus itself. So a really simple implementation of a command bus. It takes a reference to an IOC container in its constructor, as well as a collection of handlers. And a handler collection is really just like a key value map saying like this command class should map to this handler class. So we take that in the constructor as well so that can be configured elsewhere. So when we want to dispatch a command, the command comes in. We get the appropriate handler by finding the class of the command, and finding the handler that matches that class. And then we go ahead and resolve the handler out of the container and ask that handler to handle the command. Again, 3 lines of code. There's nothing to it. Really simple stuff.
Excuse me, Adam.
Yeah.
Voice of God, you hear? We've had a request to up the font size a little bit.
Sure. How's that?
There we go. That should be good. Thank you, sir.
You're welcome. So moving on, let's look at some of the other classes that we have here. There's only a couple other ones here. Here we got the add product command handler, right, which actually goes ahead and adds this product. So this takes a product repository in our constructor because we don't really want to be dealing with Eloquent directly here, right? We want to kind of encapsulate all our database logic into one kind of tight spot so that it's easy for us to mock that out because, following rule number 2, we don't want to be talking to the database in our tests. So we kind of encapsulate Eloquent behind a repository, and then in comes this add product command into our handle method. So we go ahead and extract some of the data off of that command and use that to put together this product. Once we have the product kind of built, and here the product is just an Eloquent model, but again, we want to encapsulate the actual database access inside the repository. So then we go ahead and ask the repository to add that product to the system. Let's take a look at the actual product repository. So here it is, really simple. Now, this part here is kind of interesting. This is a pattern that I've seen people use when really focusing on trying to make sure that they don't touch their database in their tests. And what they do is they pass in an Eloquent model, an instance of an Eloquent model, and they think about it more like a gateway to the database than an actual instance of a product in this case. And using that instance of product, you can access kind of the static methods that would exist on the Eloquent model itself. So what we have here, where we have this find by ID method that lets us find a product by ID, this is actually exactly the same as if we had done something like product find ID, right? Because PHP is kind of clever in the way that it lets you access static methods from an instance. But the idea behind this approach is that now we can pass in a mock here, so we're not coupled, to that static call that happens there. So anyways, we have this add method, which takes in that product that's already kind of pre-built for us that we put together in the handler, and then we go ahead and save that product. So now all the kind of database related stuff happens just in this class. So again, this is really not that complicated of an architecture, right? All the classes are kind of really short and really easy to understand. And we did all this to kind of support the ability to follow kind of these recommendations that we had read about on the internet. So let's take a look at some of these tests that we have for testing these individual classes. So I'm going to split the screen here and kind of pull these up separately. Hopefully we can fit both with this font size. So first, let's look at the products controller and its associated test. So I'll pull this over here so we got a little bit more room. What I want to focus on first is kind of this section here where we're actually putting together the products controller and asking it to store the request. So the products controller, again, it takes a guard, command bus, redirector, and then we just pass in a request to store. And because we're trying to test this in complete isolation, we only want to test the products controller. We don't want to test anything else in the application. We're passing in test doubles for all this stuff. So here we pass in a mock of our guard, which is really more of a stub. And we pre-program this to say, anytime someone asks you for the ID, just return a hard-coded 1. We don't want to actually have a real session going or real users, God forbid, in the system. We just want to return that hard-coded value. We have a spy here for the command bus, which we'll talk a little bit more about next. And here we have another stub, this time of our redirector. So our redirector, we're programming it to receive the route method. And as long as the route method is called with products.index as the argument, then we want to return this hard-coded string, which is just /products. Now, normally the redirector will return a real redirect response, not just a URL. But for our purposes, it doesn't actually matter, because what we're trying to test is that whatever comes back from the redirector, down here, is the same thing that comes back from the controller. We don't care necessarily what it is. We just want to make sure that the controller returns the right thing. So here we have a mock of our request, because we don't want to go through all the sort of hoops and hurdles of putting together a real HTTP request with headers and all this crap, because all we really care about is that this request knows how to respond to these messages, right? So when we ask it for its name with the input method, it gives us test product. Description is test product description, or the price is, 3,900 cents or $39. So we put together a mock of the request so we don't have to bother constructing the real thing. Put together the controller, go ahead and pass in our mocked request, and then we verify again that what comes back is what we expected to come back from the redirector. And here we use this command bus spy to verify that the dispatch method was called on the command bus, like we see here, and that it received an argument that kind of satisfies this set of conditions in this closure. So basically, we want to make sure that the command that came through had that user ID, that name, that description, and that price. So if we go ahead and run this test, you'll see that the test does pass, right? It's really simple. If we go ahead and make a change to our implementation, to make sure that the test is really proving that things are working, like say we made a mistake here and we were actually asking for the cost from the request instead of the price. Now, if we run this, we are going to see a failure. There's no matching handler for the input cost method. We only have one for price, so the test does fail. So we are able to kind of verify that things are working, as expected. Let's take a look at maybe one or two other ones. Don't want to waste too much time on this. Interesting ones. Here we got like an add product command handler test and the add products command handler. So here we have a test for handling a command. So again, we need to pass in a product repository, but we don't want to use a real product repository. So we create a mock and we say that it should receive the add method with a product that kind of matches this criteria, and it should receive it once. It's important that it gets called. It's a real true mock expectation. And then here we kind of create a mock command. We just kind of program each one of these getters to return hard-coded values, pass all that stuff through, and then again, make sure that the product that comes back, matches what we expect. So if we run this test, it passes. And if we were to go ahead and, make some mistake here, like say we forgot to call add, now of course, test is going to fail because we expected the add method on the product repository to be called exactly one time, but it wasn't called at all. So again, this test, it does in fact verify that this product command handler works the way that we want it to work. So let's head back to our slides for a minute here and kind of assess some things. So how do we do kind of measuring up against sort of these best practices that have been kind of passed down to us from the gods of Twitter and Reddit? Let's think about them kind of one by one. Mostly unit tests. They say you want very few integration tests, mostly unit tests. I would say, yeah, we got a thumbs up on this one. We didn't have anything but unit tests. We were able to test all of our logic with pure isolated unit tests. Never touched the database in our tests. Yeah, we didn't touch the database. We actually didn't even need to boot up the framework. None of our tests depended on really anything in Laravel at all. We only tested our classes and we mocked out any interactions with anything else. So yeah, we get a thumbs up here too. What about testable in isolation? Were we able to come up with a design that supported being tested in isolation? Yeah, we tested everything in isolation. Therefore, our design was testable in isolation. So we didn't, fall victim to this horrible, curse of writing poorly designed code because it wasn't testable in isolation. So, from the outside, it kind of looks like, yeah, we did a good job here. Everything's good. We really nailed it here. But if you're anything like me, you might kind of feel a little bit weird about certain aspects of these tests. I'll show you what I'm talking about. Let's head back to the code. Let's go to the products controller here and the products controller test. So you guys all probably know that in Laravel, there's multiple ways to get fields from the request, right? You can call request input. You can access the request as an array. You can access the fields as properties directly on the request. So say we thought, this is kind of verbose. Maybe we want to switch to the kind of array access style. So say we went ahead and replaced all this stuff. Instead of using request input, we just accessed it this way. And we think, okay, yeah, that's a nice little refactoring. I think this is a little bit nicer. Let's go ahead and run our tests and make sure that we didn't break anything. Oh, what the hell? Offset get doesn't exist on this mock object? Oh, man. So our mocked request only knows how to respond to input. So when we change this to use the array access style, all of a sudden our test breaks. Now, we kind of know, like, you know what? It shouldn't really have broken there. Like, the system still works because we know that the request does the same thing in that case as it does with input. So let's just go ahead and update this test. We'll just say it should receive offset get instead. And we go ahead and run our tests now. And we got a mistake because we didn't fix this back to price. If we go ahead and run the tests again, back to green. Okay, so we've updated our tests to match the change that we made to our code, and we're all good. Maybe we want to make another change, or maybe someone else on the team writes this code a little bit differently. Not everyone knows that you can get the ID of the current user directly from auth. What a lot of people might do is they might get the current user from auth and then ask the user for its ID. This is going to return the exact same result as it would have returned otherwise. So if you go ahead and run this test, you might think, well, it should pass. But of course it doesn't pass because our mock of our guard has no idea how to respond to user. It only knows how to respond to ID. So this kind of sucks, right? So we've got to kind of keep that implementation or go and tweak our test. Another example, what about the redirector? So this ultimately is just going to return a redirect to /products, right? And we have a named route for products.index. Really, there's no reason that we shouldn't be able to just return that redirect to /products. It's going to return the same URL ultimately at the end of the day. So shouldn't the test, still pass? Well, if we run the test, it fails. The redirector only knows how to respond to the route method and only knows how to do it with the products.index parameter. So we're really tightly coupled to this sort of implementation. So when I see this stuff, it kind of starts to really bother me. I'm thinking, all right, so yeah, we can test everything in isolation. We don't touch the database. Everything is tested in these finely, tightly grained unit tests. But like, what the hell does that matter if I can't even refactor my code? Like, isn't the ability to refactor my implementation more important than adhering, to some of these recommendations that people have kind of cast down upon me? So if you were to go and ask, any of these people that would tell you that that's the way you should be running your tests, this is what they would say. They would say, you're still doing it wrong. You have no idea what you're doing, man. You know what? Your design is still complete trash. It's still terrible. That's why your tests suck and make it hard to refactor. It's not because of the fact that isolated testing doesn't make it easy to do this stuff. It's because you just don't know what you're doing. One day, you'll figure this out, maybe, if you're lucky, and then you can be a real professional developer like me. So you're sitting in your corner kind of feeling like, oh man, this is frustrating. I'm trying my best. I'm implementing this fancy architecture, but somehow my design is still terrible. I'm using a command bus. I'm using repositories. I'm encapsulating my database access, doing everything that I can to try and follow, these rules that people have told me I'm supposed to be following. But for some reason, my code is still terrible and it's still my fault. So I'd like to take another look at the code that we have here and think about it through the lens of refactorability and kind of try and address, what is the reason that we can't refactor this stuff? So we've seen that, whatever method we use to access the fields off the request has to be the same method that we've specified in our test, right? We can't use one here and a different one there. So what could we do differently such that we could use any of the methods on the request that give us the field back without having to change our test? How could we change our test to kind of give us that flexibility to refactor that we want? Well, the first thing that comes to mind for me is, using a real request instead of using a mock. If we used a real request, we could call any methods we wanted on it. As long as the value came back correctly, everything would still work. But then our test wouldn't be isolated. We'd be using a real request, not a mock. So, oh man, that feels really uncomfortable. What about like the guard? Well, if we had a real guard and we had a real user and we logged that user in, then as long as we asked the guard for the right things in such a way that eventually give us back the ID, then it would work. We could ask for it in any way that we want. We could ask for the ID directly. We could ask for the user and get the ID. We could even ask for the user from the request. You can do something like this in Laravel too, right? You can say request user ID. Of course, this test isn't going to support that refactoring. So, how could we support that refactoring? Well, using a real guard would fix that. Same with our redirector. If we wanted to allow using to and then the URL, or using action and then the name of the controller action, using a real redirector would make that really easy, wouldn't it? So it got me kind of thinking, is the problem really me? Is it really that, I just haven't figured this stuff out yet and this is the right way to test and everyone telling me that this is how I should be doing things is right, and if I just keep banging on it long enough, eventually I'll figure it out? Or maybe is there like a more fundamental problem here? So I started kind of thinking back to sort of the fundamentals of test-driven development and kind of the roots of TDD. And TDD, at its core, is all about this, the red-green refactor loop, right? The idea is that you write a failing test, then you do whatever you can to make that test pass. That might mean one big 60-line function, one big nasty function. Get the test passing, though. That's the goal. Once the test is passing, then you refactor the implementation as much as you want. You clean it up. Maybe you extract some private methods. Maybe you create some new classes. Maybe at the end of the day, this 60-line function turns into one class that you're interacting with that delegates to 3 other classes that have kind of finely grained responsibilities, right? And all that stuff is covered by this single test because you were just kind of refactoring the implementation and keeping that one test green. But all of a sudden you start thinking, well, that's not isolated unit testing. If I have one test and 4 classes and the behavior of those 4 classes is covered by this one test, I'm not testing in isolation anymore. I don't have discrete unit tests for each class that isolates it from all its collaborators. So when I started realizing that, refactoring and the ability to refactor is like a core activity of TDD, it kind of made me realize something. And this is something that I wish someone had told me many years ago when I was trying to learn this stuff before I beat myself up for years and years trying to do it, the right way. So I'm going to share it with you today. If refactoring is a fundamental part of TDD, a core activity of TDD, there's 3 parts of TDD, and this is one of the big 3. And isolated testing gets in the way of refactoring, makes it hard to refactor, doesn't let you refactor, then isolated unit testing is incompatible with test-driven development. All right? I'm sick of feeling like it's my fault that I can't get this stuff to work. Instead, I think it's the system's fault. I think it's the recommendation's fault. I think that I'm a perfectly capable developer. I know what I want for my test suite. And from what I can tell, isolated unit testing is never going to give me what I want. Isolated unit testing forces you to figure out the exact design that you want to land on at the end of the day, up front, at the beginning. You need to kind of figure out in your head, okay, well, what are all the classes that are going to be involved? Okay, and I think this is how it's going to work. Let's test drive each class individually and mock out all the interactions. And then, only then, at the end of the day, will you end up with discrete unit tests for each class. And you had no chance to refactor because you have to get it right the first time. To me, it's almost like instead of this test, where we're asserting that we get this response back and that the command bus was interacted with in this way, it's almost like we had these assertions and that we wrote our test to look something like this. Assert that the code on line 26 is command equals new add product command. Thumbs up. Assert that the code on line 27 is this auth ID. Oh, good to go. Now, if this was a real assertion, this would fail for all the same reasons that our current test fails, and in all the same circumstances. So, to me, that's no good. So, what do we got next? I want to talk about an alternative approach. Diagram time. This is kind of how our system is set up right now. Here's our products controller, and here's our test. Our test tests the store method with a request and gets a response back, and we mock out the guard and the redirector, and we set a mock expectation on the command bus. Here's our test for the command bus, right? It tests the command bus only, which interacts with everything else as testables. Same sort of thing for our add product command handler. You know, it uses a fake repository. And same thing for our product repository. It uses a fake gateway, and it has a fake product that comes in that it calls save on. Here's kind of what the whole system looks like together. We've got this products controller that talks to the command bus, but we faked it out here. And now the real command bus works this way, but it talks to a fake container and has some handlers. And here's a real handler, you know, that talks to a fake repository, but here's the real repository. The way that our tests are kind of set up right now, we've created these boxes. And at best, we can only ever refactor inside of the box. And as you've seen with our current tests, that's actually not even totally true. There's a lot of refactorings inside the box that we still can't do. But there's certainly no way for us to move responsibilities between any of these classes or shift things around. We sort of created these hard boundaries around things. And if we change those boundaries, our tests are no longer going to be valid. So if we want to maximize our opportunity to refactor, then what we really want to do is create a bigger box. This is the box that I like to start with when I'm implementing a new feature in an application. This box represents our entire app. The input into the app is the HTTP request. The output is the HTTP response. And maybe there's some other side effects that happen too that we want to assert against. I like to try and think of the HTTP boundary to my application as almost just like a big function. Like the whole HTTP request response cycle is just a function. I just want to test that that function does what I want it to do. That's how I want to start, because that gives me the most flexibility to tweak my implementation, reorganize things, move responsibilities to other classes, extract new classes. You know, and if refactoring is something that you care about, then I think this is the way that you should think about testing too. So let's check out some code again. I'm going to check out a different branch here, and I'll show you this alternative approach. So let's check out this integrated branch. Okay, close some of this stuff down that's not real anymore. All right, so here I've got this new test called add product test. And this is like an HTTP level sort of feature test. We've thrown away the rule book. We're not worried about isolation. We're not worried about touching the database. We're not worried about any of that stuff. All we care about is defining what we want to happen in terms of what the response should be and what the side effects should be, and then giving us the most opportunity to refactor inside that big box as possible. So we create a user using a factory, no big deal. We log in as that user using a real auth system. We make a real post request to a products endpoint. We pass in some data, which is going to get turned into a real request. And back comes a real HTTP response. Now we can assert that we were redirected to the product.index route, and we can fetch the first product from the real database and verify that, yes, the product belongs to the user that was logged in. Yes, the product has the same name we passed through, has the same description, and has the same price. I haven't gone ahead and implemented this yet. Let's implement it kind of on the fly here. So we run this test. We get an error, method not allowed exception. So that means there is a route defined for this endpoint, but it's not a post route. So let's go ahead and check out our routes file. So here we do have our product's index route, but we want to add one to store the product. So let's add a new route to kind of fix that failure. We'll make a post request to products, and sure, it'll still talk to the products controller, but this time we'll use a store method maybe. And we'll call that route products.store. Why not? Let's go back and run the test again, see what the next failure is. Scrolling on up, Products controller store does not exist. Okay, let's head over to products controller and add the store method. Run this feature test again. And okay, we got a 200 back, but we wanted a redirect. Okay, let's try and fix that. So we want to make sure that we get redirected to that route. Okay, cool. Let's use a redirect helper. Again, we're just trying to get this done as fast as possible so that we can refactor. So we'll redirect to the products.index route and keep working through this, trying to get it green. Okay, so now we're trying to get a property of a non-object here on line 30. So that's right here where we're getting the product and fetching the user ID off of it. So at this point, we're going to have to go ahead and actually create a product with these details. So let's just quickly implement that. We'll get the current user. We'll just use the facade. And using its products relationship, let's create something here where we can get the name. It's going to be, we'll use the request helper. Why not? Screw it. Get the description. And we'll get the price. Oh. Okay, so with any luck, if we did this right, maybe we'll be onto a new error or we'll be passing. Okay, great. Our test is green. So we've successfully implemented this in kind of the simplest way possible. And now we can kind of do any refactoring that we want to do. Like, okay, say we decided we did want to take the request as an argument. Okay, let's have the request come in. Let's run the test again. Still green. So our refactoring is successful so far. And instead of using the helper here, let's use request input. Sure. Still green, so we know it's still working. We can go through this whole thing and switch that up as much as we want. I'll even say that, we can actually go so far as to refactor that whole implementation to the point that back to our isolated example where we have the command bus and the handler and all that stuff, I still have that same test here, just hanging out. Here's the same test from the integration test suite. Would you believe that this test passes even in this totally different design that we had before? You might not believe that this test is actually passing. So let's go to the products controller, maybe make a change. Let's say we had that same tweak here where we're using cost instead of price. If we go and run this test now, we get an error. The test fails because we forgot to fill out the price column on the product. Good to know. It's not quite as targeted of an error as we had before, but the test still fails. So the fact that this test is passing, that's telling me that it's really proving that things are working here. So if we wanted to go back to, say, our product repository test, maybe, and our product repository, and just kind of compare what happens when we make a change here. Oh, is this stupid thing going to go away? Versus when we make a change in the integration test. Say we forgot to call the save method here on the product, right? And we go ahead and run the product repository test. And we see, oh, okay, we forgot to call save, so the test fails. Thank goodness we had this unit test, otherwise we never would have known, right? Well, if you run the add product test, the feature test, what do you know? It fails too. Again, the description of the error isn't quite as clear, but it still totally fails and it still totally proves that it works. So far as I can tell, there's not a single change I can make to any of our classes that would cause our unit tests to fail, but wouldn't also cause the feature test to fail. So not only that though, not only does our feature test cover all of the different cases, that are covered by these other tests and fail for every situation that would cause the unit tests to fail, our feature test also allows us to refactor things in a way that our unit tests never would. If we went back to our products controller here and we decided to make that change where we're using kind of the offset get sort of approach, then, running the feature test still passes. But like we looked at before, the actual product controller test fails. So not only, again, does our feature test cover all the same failures that our unit tests cover, it also enables any number of possible implementations and refactorings, whereas our unit test, our isolated set of unit tests, is tightly coupled to one specific implementation. This is why, in my opinion, isolated tests are a scam. for every 5 isolated tests that we wrote here, we only had to write 1 feature test. Those 5 isolated unit tests, they only support 1 implementation. Our 1 feature test supports n number of implementations, as many as we want. Now, I'm not saying that this is all you need and that you should only ever test from the HTTP level, but I'm saying that it's a useful place to start because it does give you the most flexibility in terms of refactoring. So, common questions that come up. What about redundancy? What about trying to make sure that you're not over-testing the same code over and over and over again, right? I'll show you an example of what I'm talking about. Say we were to check out this other branch I got here. And here in the routes file, I've added another route. So we got 2 endpoints for storing products now. One where it's stored through a form, and one where it's stored coming in as like JSON. Taking a drink. So let's take a look at the feature test. I've gone ahead and added this and the controllers, and we'll kind of take a look. So we have the existing test that we had before. I've renamed it, so it's adding a new product via a form. Again, same thing that we had before, no different. Here we have the test for adding it via AJAX. Now this is very slightly different in the sense that we want to make sure that we actually get a JSON representation of the product back after we create it. And we also want to pass in the data in a slightly different format. You can see we have this extra data key here, and that's where the things are getting passed through. Whereas with the form implementation, it's just coming in at the top level here. So let's go ahead and run this test and kind of see what's up. Okay, so the test is passing. I'll show you kind of the implementations of both of these. And in this case, I'm actually using that sophisticated, complex architecture that we had with the command bus and the handlers and all that stuff. So here's the products controller. Again, it takes like the add product command and dispatches that and then returns a redirect. But here we have this JSON products controller. And this one's very similar. It takes the command bus. We put together a command, but you can see we're doing it slightly differently. We're getting it from the data key, right? So we're putting together the command based on this slightly different input here. And then we're returning the product as JSON versus returning an actual redirect. So a common thing that someone might say is that, in both of these tests, we're needlessly executing all of the command bus code, all the command handler code. These verifications here to verify that the product got saved to the database, which we're more or less doing in both cases here. This is kind of redundant, right? Like, as long as we know that the command handler works, then we don't need to verify that again in both controllers. There's 2 kind of sides that you could take here, and it really depends on your circumstances. So I'll talk a little bit about both. On one hand, maybe that's fine, because maybe you want to afford yourself the flexibility to only use the command handler on one of these controllers. Maybe in the JSON one, you just want to do it directly with Eloquent, and testing it this way, you could make that refactoring and that would work. But on the other side, if you've decided that this command bus is like an integral, stable piece of your system architecture, and you want that to be there for sure no matter what, then maybe it is worth tweaking these tests such that you are not duplicating that effort. So I'll show you what it might look like to make that change. Check out another branch here. Spabus 2. Okay, I made some changes here. What we've done is we've decided to introduce a boundary between the controller and the command bus. We decided that we only want to test that the request comes in, does the right thing with the command bus, and then comes back. And then we want to test that the whole command bus side works properly on its own too. So this is what it looks like. We create a user, and then instead of using a real command bus, we replace the command bus that's in the IOC container with a mock. And we say that the mock should receive dispatch with a command that matches these, fields. And then we do, in fact, make sure that we get the redirect coming back. So let's run just this one test here. You can see that it does pass. Down here, we got a similar sort of thing. We create a user. We create a mock of the command bus again and say it should receive dispatch with a command that matches these fields, and return a product that's kind of been put together so that we can get the JSON off of it. And now in our assertions, all we're really worried about is getting back the right JSON. and making sure that we do in fact have this method called on the command bus. So what we've kind of done is separate the responsibilities of our tests a little bit. So now all that the add product test is responsible for is making sure that the controller translates the data correctly, dispatches the command, and returns the right response value. It's not an isolated test by any means. It's using a real request. It's using a real auth. The only thing it's not using for real is the command bus. We're using a mock of the command bus. But otherwise, it is still integrated with all those other pieces. So we still have that flexibility to refactor. So we could, interact with the request differently if we wanted to. We could use input. We don't have to just use this, helper method version. And if we go ahead and take a look at our add product command handler test, I've modified this a little bit too. So instead of being an isolated unit test now, we've resolved the product command handler out of the IOC container so it gets all of its real dependencies. And we just move that assertion about making sure that the product gets saved from our feature test into the command handler test. So now we handle a real add product command, passing some stuff through here. And then we get the first product in the database and make sure that all the stuff is set on it. So I'll show you what we kind of done. We're not doing any isolated unit testing. We've introduced kind of a boundary where we only want to test on one side in one place, and then everything else we just want to test that it interacts the right way. Let's check out the slides here. I got another diagram. So here's what we had before, right? We're treating the whole system as a big black box. And ignore these boxes. These are where our unit tests were, but we're not really even thinking about those anymore. What we've done is we've kind of cut it up into sort of two subsystems. So the HTTP request comes in and the response comes out. And we're treating this whole thing, the controller, the request, the router. This is the real guard, real redirector, but we're using a fake command bus. So we have all the flexibility in the world to refactor inside of this box. But here we've introduced a boundary where we talk to the command bus where we've said, okay, the way these things communicate is stabilized, and we feel safe to replace this with a mock now. So now we treat this whole side as its own subsystem. So the add product command handler uses a real repository, real gateway, real product, saves stuff to the database, all the flexibility in the world to refactor inside of this box, but we've reduced that redundant testing stuff. Again, I'm not saying that this is necessarily what you should do. I'm saying it's an option. Personally, I would have actually been totally fine with just duplicating those assertions about the database up here. It's not until it really starts to become obvious that you're duplicating this stuff over and over and over again, and they're introducing a different type of coupling that it's worth thinking about switching. So what else we got here? I think I got one other point to make. The other question that people ask about a lot is external services. So if we're focusing on working at the HTTP level and treating the whole system as a black box and testing everything at once, what about like calls to Stripe or stuff that you don't control? People might think, well, I'll give you the database. You can run the database locally. That's no big deal. But if you're going to make payments somewhere, like how are you going to write an integration test that does that? Are you going to talk to Stripe every single time you run an integration test just to verify, that this product gets marked as paid for, or something like that? No. I'll show you another example, this time from a different application. So this is actually an example from my test-driven Laravel course that I released a couple months ago. Kind of simplified, but it's a test for testing that a customer can purchase tickets to a published concert. So we create a concert with a ticket price of $32.50, and we add 3 tickets. And then here, using this helper method I've added to my payment gateway, I capture any new charges that happen while we run this request. There's some details around why this needs to happen. It's related to how Stripe's testing environment works. You can't clear out all your test data from the API. The best you can do is set like a marker and say, okay, I only want to look at charges that happened after this charge. So we can't just clear it out at the beginning and then see what's there at the end. Instead, we kind of have to create a window and look at that. So that's the reason for this sort of closure-based API. Anyways, you make a post request to concert orders saying, John wants 3 tickets, and here's his valid payment token that we got from the payment gateway by using a test card to get a payment token back from Stripe. We make sure that the order was, got a created status coming back, that the order JSON matches what we expect, and then we verify that 1 charge happened. So, capturing these charges gives us back a list of all the charges that happened. So we want to make sure only 1 charge happened and they weren't double charged, and that the sum of all those charges, in this case it's the value of the 1 charge, is 9750, which is 3 tickets. Then we just make sure that, the concert does in fact have an order for John, and that order does have 3 tickets associated with it. So let's run this test. Right now, this is going to actually talk to Stripe using test credentials and all that stuff. So it's going to be slow. So it usually takes about 2.5, 3 seconds to run. So 2.95 seconds, actually talked to Stripe, verified that everything worked completely end to end. Now, this isn't ideal because you don't want your tests to have to talk to Stripe. Like, you can't run your tests when you're on an airplane now, or your tests are needlessly slow. So what I like to do is I like to replace these dependencies, similar to what we did with the command bus, where we replaced it with a mock. You could use a mock, but what I like to do is I like to use what's called a fake. So the easiest way for me to explain a fake is to think about some of the things that already happen in Laravel's testing environment. So Laravel has like caches and sessions and queues, right? And if you look at the PHP unit configuration file for a Laravel project, out of the box, you'll see that the cache driver that we're using in the testing environment is an array. So when you cache something, it's just storing it in an array in memory. And once the request is finished, that cache item is actually totally gone. But from the perspective of the rest of the application, it's a totally legit cache. You can call any methods on it you want that exist on the cache interface, and they'll all kind of work the way they're supposed to. So if you put something in the cache and then ask for something, it'll actually come back. Unlike a mock where you'd have to program all that stuff every time, you actually build like a real implementation that really works, but just works in a very simplistic, sort of naive way. The session works the same way. For the queue, we have the sync driver. So you push something onto the queue, and it happens right away instead of happening in the background. It's not a real queue, it's a fake queue, but it's not like you're just stubbing one method at a time. The whole thing works. Like, everything interacts the way it's supposed to interact. So I like to take the same sort of approach for my external services. So I'll show you the actual Stripe payment gateway here. So the Stripe payment gateway implements this interface called payment gateway. And that just has a charge method where we want to charge some amount using some token. And then it has some helpers for testing because I want to be able to test that this works. So I can get a valid test token, and then I can track the charges that happen during some callback that I pass in. So here's a Stripe implementation. We construct it with our API key. Charge actually uses Stripe's SDK to go ahead and charge out to Stripe with our API key. And then valid test token, it passes in a real test card to Stripe and gives us back the token. In new charges during, just captures all the charges that happened by making yet another request to Stripe to get all the charges that ended before a certain charge in the kind of paginated list. So that's a real implementation. Here's what the fake implementation looks like. Again, it implements the payment gateway interface, but this time charges is just a collection, just an array. So when you charge, first we validate the token to make sure that it is the same as the valid test token that came back. So it does behave like the real payment gateway, right? It's going to reject any charges that try to happen without what it considers to be a valid token. But then we just store that amount in this list. And we just build that list up over time. And then new charges during just lets us slice those charges and give back all the charges that happened during that callback. So from the perspective of the rest of the application, inside of a single request, this fake payment gateway acts exactly like Stripe, except it's faster. So here in our test now, up here where I'm taking the payment gateway from the container and storing that as instance state so that we can reference it down here, we can replace the Stripe payment gateway with our fake. So now we're using a fake implementation of the payment gateway in this test. We can run the whole test, and it passes in 100 milliseconds instead of in 3 seconds. We didn't have to change anything in our code. We didn't have to change anything in our tests because this fake payment gateway is really just like a local driver for our payment gateway. And that's been a really useful way for me to think about test doubles lately because it still lets me write tests from this sort of integration style approach, but still isolate myself from things that I don't want to be talking to in my tests. If you're interested in learning more about testing like a real Stripe payment gateway, the digital kind of swag bag that you're going to be getting at the conference, I included sort of a mini course on testing stuff that talks to Stripe. So definitely check that out. So to kind of finish up, this is kind of the message I want to leave you with. don't worry about isolation. Stop thinking about isolation as a goal, as something that you're trying to achieve to ensure that you have well-designed code. Instead, introduce boundaries in your system. You might have integration tests on both sides of the boundary. It doesn't mean everything has to be isolated, but introduce boundaries when they solve a real problem that you actually have, not just because you're trying to satisfy the isolation gods on Reddit or anything like that, right? So never introduce any of this stuff just because some idiot on Reddit made you feel like a bad developer. Do it when it actually solves a problem for you. Most of the best practices and advice that you're going to read out there come from people who don't know much more than you. They just think they know a lot more than you, and they're just parroting back bad advice over and over and over again. Think for yourself, come up with creative ways to solve your own problems, and write tests that give you the value that you're looking to get from your actual test suite. So if you learned anything from this presentation or found it interesting, I have a whole course on test-driven development with Laravel where we build an entire application from start to finish. And right now you can still get early access into the course for 40% off, but that early access sort of launch price is going to be going away over the next couple of weeks. So if that's something you want to check out, now would be a good time to get in there and save a ton of money. You can find me on Twitter at Adam Wathan, and I blog about testing and object-oriented design and stuff like that on my website at adamwathan.me. Thanks, everyone. Hope you enjoyed the presentation.
That was awesome, man. Fantastic. They're taking up a collection in the Slack room for your personal safety to try to protect you from the Reddit horde. So we'll see how that goes. So we have time for a couple questions here for you. What about some came up a few times about like repos and things of the like are you still unit testing repos, or how do you kind of handle that?
Sure. So I think if you're going to take that approach of, I'll share my screen again.
Sure.
If you're going to take that approach of actually trying to encapsulate eloquent stuff behind a repository, I have kind of strong opinions about it. I don't think it's a good idea. But if you are going to do that, then I don't think this approach is the right way to do it, where you like mock everything out. I think the better way to do it is to write the repository like this: no dependencies, no constructor, anything. Here where you do the find, just find the damn product. Like that's it. Right. And then integration test your repository against the database. So when we go to write this new repository test now, we might have, use database migrations. I'm going to comment this one out because I don't want to think about it right now, and it'll probably cause our test to fail. And here where we're trying to find a product, instead let's just do like, product equals factory products class creates. Do I even have a factory for products? No. Anyways, you would create the real thing, and then you would new up the product repository, which no longer has any dependencies. And then I would do something like found product equals repository, find by ID, and then I would do something like, this product ID. So we get the ID from the product that we actually saved to the database. And then you just want to make sure that they're the same. Usually this doesn't work because they're not the same instance in memory. So I usually end up doing something, like making sure that the IDs of them are the same, or, I think there's like an assert true on something like this. I think you could do assert true product is found product or something like that. I'm pretty sure that's a method that comes with Eloquent these days. So I would take this kind of approach and write a real integration test for the repository, but then anywhere where you actually use that repository, like, in your command handler, like we have here or whatever, here you could actually use, a test stub now. So you could test this without touching the database if that's something that you actually care about. In my experience, it's not as big of a issue as people think. So.
One more, I think one more, maybe, well, there's a lot more in there for you after, but what about organizing, so like if you have a more sizable app, and like, how do you organize all these feature tests? Like, do you get down into directories, or just one giant, folder full of individual feature tests with hundreds of features? How do you kind of go with that?
I don't think there's like a rule, a best way to do it. What I've usually done is had like a features folder, and then just basically dumped features in there until it felt too big, and then look for kind of groupings and be like, okay, well, this is related to creating or adding new products. So let's make a new folder for like adding products, or maybe we make a folder for API, or it's really just up to you. Like it really doesn't matter. It's just whatever makes it easiest for you to find the things that you're looking for and avoid, I guess, naming collisions and stuff.
Right.
Yeah.
Awesome. Well, that's great. Thank you very much, sir.
All right.
Hang out in the Slack room after and check out. A lot of people are freaking out in there and have questions for you and compliments. All right, so let me just do a little business here. I can kick you off later. Okay. All right, so we're going to take, ooh, got a little close there. We're going to take a little mingle break.